Welcome back guys to your integral calculus. So let's continue your discussion. Now we are done with your module 1, unit 1 to unit 4. Okay, so let's have a recap. In your unit 1, we had your discussion regarding your introduction. And then unit 2 is your power formula. Unit 3 is your exponential function. Unit 4 is your logarithmic function, and then this is your unit 5, which is trigonometric function. Okay, so integration of trigonometric function. Okay, so our unit learning outcome for this presentation is to recall your trigonometric identities, because we will be needing all of these in integrating your trigonometric functions. Okay, and another is to integrate, of course, your problems with trigonometric integration formulas. So to be able to integrate trigonometric functions together with, of course, using your trigonometric identities. Okay, so recall in your trigonometric identities, this is supposed to be discussed in your trigonometry. Okay, so just recall. So this is your reciprocal identity. Okay, you might already know about this, but for the others who forgot, this is your reciprocal identity, wherein sine is the reciprocal of cosecant, therefore that is vice versa. You can cross multiply your sine and your cosecant, yes, and that is reversible. Okay, so cosine is inverse of secant, and so with tangent, inverse of cotangent. Your quotient identities are tangent, so you can break this down if you need to. You can break this down into sine over cosine. So with cotangent, since tangent and cotangent are reversible, their breakdown are also reversible. Okay. Double angle identities. Okay, you have here your sine twice your angle theta is equivalent to 2 sine theta cos theta. And if that is cosine twice theta, then this is your equivalent cosine squared of theta minus sine squared of theta. And of course, another transformation or identity for that double angle of cosine is 2 cosine squared theta minus 1. And we will of course not forget this is the most important, and actually this is where double angle is derived, your Pythagorean identity. Okay, so sine squared theta plus cosine squared theta is equivalent to 1. If you will try to divide this first Pythagorean identity by sine squared theta, then that will give us your second Pythagorean identity, which is secant squared theta minus tan squared theta equals 1. And if I will do the other way, instead of dividing by sine squared theta, I will divide it by cosine squared theta. That will give us the third one. Okay, so that is just a simple recall in your trigonometric identities. So let's start with the integration formulas of trigonometric functions. Okay, first is your sine function, wherein we are integrating sine u du. Again, u stands for a function and du stands for its complete derivative or differential. Okay, so before we will apply this formula, you need to make sure that your function u has its complete differential du. Okay, so that is a common mistake before on others. They are applying the formula, but du is not complete or not present. So that's it. Integral of sine u du is negative cosine of the same angle u plus, of course, your constant of integration c. Then cosine is sine u plus c, and then tangent is negative ln cosine u. Okay, negative ln of cosine u, of course, plus c. There are proof of these integration formulas, just like this tangent. You can see this one in the book of Oy, the one that we showed you, not the Rainbill. But actually, this is also present at the book of Love in Rainbill. So since we do not have that much time to present the proof of all of this, So maybe it's your task to go to your book and then know how did this formula originated. Okay, so we'll try to look here on this side. Okay, so these are all logarithm. This tangent, cotangent, secant, and cosecant. So you can see again the proof of this on the book. But if you try to look here on the right side of our screen, these are actually the reverse of your, what we call this one, derivative of trigonometric functions. In your differential calculus, you discuss on what are the derivative of tangent, cotangent, secant, and cosecant. Actually, these are just the reverse. If you will integrate both sides, then you will cancel the effect of derivative, so it will go back to these functions. Okay, so before, the derivative of tangent is secant squared. So if we will try to get the antiderivative by integrating, then it will go back. The integral of secant squared will go back to tangent. Same as this cosecant squared, this secant tangent, and then cosecant cotangent. Okay, so these are your ready formulas for trigonometric functions. So let's have an example. Okay, your formulas are here. The formulas that you will be needing in solving these examples. Okay, so that we will not be going back to this slide. Let's have this first example, integral of sine 4x dx. Okay, so again, this belongs to your first formula, of course, integral of sine u du. But we need to check if there is really a complete derivative of our function u. Okay, so if you'll try to look at our example, sine 4x. So the function u there is your 4x. So if I will differentiate your u, that will become your du. The derivative or the differential of that 4x will be 4 dx. Is that present in our equation, original equation? Okay, actually no, only dx. There is a missing, which is a constant 4. So we can add that one. Okay, we can put that one together with dx, but we need to balance that one by 1/4. So okay, fortunately it is not shown here, step-by-step process, but the same as before. If you have a balancing factor or you need something in your du, you can add that one, but you need to balance. So that is what happened here already, but it is not presented. Okay, therefore if you have there the balancing factor, which is 1/4, the integral of sine is negative cosine of the same angle. So this is now the integral, which is the negative cosine of your u. Your u is 4x, and that's it, plus your constant of integration c. Therefore, your answer could be simplified as negative 1/4 times cosine 4x plus c. Or if you want, you can put that cosine 4x on top, so that will be negative cosine 4x all over 4. Okay, so that's it for example number 1. Okay, number 2, let's have this one. Okay, it looks complicated, but of course, let's try to find a way to simplify this one so that we could apply these formulas. Okay, exam problems will not always be in the form of these formulas. So you need to make a way by simplifying so that you can make use of these formulas before you will make use of these formulas. Okay. So if you try to look at this example, it looks complicated because of this bar. And you have there 1 plus sine 2x all over cosine 2x. So in the solution here, what happens that we can distribute, since your divisor is just a single term, why not distribute it in each of the term in your numerator? So that is what happened here. Therefore, if I will distribute, then that will become 1 over cosine 2x. Wherein I do not have that form in my formula. Therefore, why not convert this one using your inverse, inverse trigonometric identity. What is the inverse of cosine is secant. Isn't it? Okay, so that will become, instead of integrating 1 over cosine 2x, that will now become secant 2x. So do we have that formula here? Yes. So later on we can integrate that one. Okay. So how about the second one? Integrating sine 2x all over cosine 2x. There is no form such as this in your formula. But in your trigonometric identity again, sine of angle over cosine of the same angle is equivalent to tangent. Okay, so we can rewrite that one into tangent 2x. Therefore, we are now integrating this secant 2x plus tan 2x, the quantity multiplied to dx. Therefore, I can distribute the integral and your dx in each of the term. Then that will just be focusing. Okay, let's focus here on the first one. Integral of secant 2x dx, that will fall under secant u du. So let's try to check. If your u is 2x, because that is sec 2x, right? So your u, or the angle or the function, is 2x. So the complete derivative or differential of that should be 2 dx. However, there is no 2 together with dx. So I will add there 2. At the same time, I will balance that one by 1/2 before I will apply your formula. So that is where this 1/2 came from. Okay, now apply the formula. Since let's say I will put there 2 and balance it by 1/2, so there is no problem. Then the formula for that, the equivalent of integral secant u of du is ln sec u plus tan u, plus of course plus c. So secant, your angle 2x plus tangent 2x, c, we will put that one on the last part because we are not yet done integrating the other term. Okay, so the second term is the integral of tan u, wherein that will fall here in this formula. Again, but let's check. Your u is 2x, du should be 2 dx. So there is a missing 2. So I will add that one and at the same time balance that by 1/2. But the integral of tangent is negative ln. So that's why your original plus here became minus in our answer. And then ln cos u. So your u again is 2x. And that's it. We are done integrating. So there is no integral sign. So we are now ready to write down your constant of integration c. So that's it. That is your answer for number 2. Okay, number 3. Again, we will try to look at our example or our problem. There is no ready form of integration for that type of equation. Okay, so as you can see, it is 1 plus secant x, the quantity raised to 2. So there is no such form in this formula. So we will again try to simplify. So the only choice that we have is to expand, since there is no other way for us to simplify this one. So if I will expand, expanding binomial, that is your algebra of course. So that will be the result, 1 plus 2 secant x plus secant squared of x. So now, this is again just a distributive property of integration. We can now distribute the integral sign in your dx inside. So we have now integral dx, which will become x, and then integral of 2 secant x, you can bring outside your 2 since that is just a constant. It is not affected by integral. So we will just worry about integral of secant x dx. And that will fall in this formula here. So the answer will be ln sec u plus tan u. And let's check again. Sec u du. Okay, so your u in this problem, okay. Where's my pointer? Okay. So the value of your function u is just x. So the derivative will be dx, which is correct. So that is now complete. We are now just to apply your formula. Therefore, the integral of that together with your constant 2, which is factored outside, is ln sec u plus tan u. Okay. So now, for the third term, integral of secant squared dx, that falls exactly in this formula, secant u squared du. Okay. So again, your u is x, and it has its complete du, which is dx. Therefore, integral of secant is just tangent u, plus of course your constant again of integration c. Okay. Example number 4. This will be your final. Your fifth example will be your sheet work. Okay, for you to try if you understood how to apply these formulas. So number 4, let's try to have this. Again, there is no ready formula for this. So let's try to simplify first. So cosine cube of x times dx all over 1 minus sine x. So our way of simplification, there is no such identity to break down directly your cosine cube. So let me separate, but we have of course an identity for your cosine squared. So why not separate or bring outside one of that cosine? So that we will break this down into cosine and then cosine squared. Then if we will try to recall your identity, this is from your Pythagorean identity, you have this sine squared plus cosine squared equals 1. So let's try to make use of this. So we will try to change this cosine squared. So if I will try to manipulate this one, that will be equivalent to 1 minus sine squared of the angle. So cosine x will remain as cosine x. We will change that cosine squared using this again, derived identity that we had. So that will be equivalent to 1 minus sine squared of your theta, but your theta of course is x since that is our angle a while ago, and all over 1 minus sine x times dx. Nothing still happened here. Okay, nothing happened yet. Okay, there is no simplification happened. We just try to change the form of your cosine squared. It is still not integratable. So if you will try to look here at 1 minus sine squared, that quantity, this is a binomial or a quadratic which is factorable by some indifference in your algebra, right? So that is what we will be using. We will factor this 1 minus sine squared because 1 has a perfect square and sine squared, of course, is a perfect square. So that will just become some indifference because your operation here is minus. So if you are not yet convinced with this, why not multiply again? That should go back to 1 minus sine squared of x. Okay. Now if that is now transformed into this form, there is exactly a function which is exactly the same as your denominators. Of course, that will cancel. So we are now left with cosine times the quantity 1 minus sine x times dx. Okay? So all we need to do now is, if I will try to multiply or distribute this integral cosine x and dx inside, that will give us this next solution here below. So you will now just be integrating cosine dx, x dx, which is applicable in this formula. And the second term is sine x cosine x dx. Okay, let's worry about that later on. But first, let's try to integrate cosine x dx. Again, that will fall under cos u du. Okay, so the answer for that, since x has its dx completely, that is just sine of the angle u. So that will just become sine x. And if you will try to focus here on the second term, it looks like a product, but actually, okay, if you will try to consider one of these, let's say, for this solution, we separated here sine x. So let's say that is the formula that is applicable. How about this cosine x dx as its partner? Okay, if you will try to recall your derivative, if we will say that sine x is our u, and we will differentiate that u to become your du, and the differential of that sine x is cos x dx, which is exactly this remaining part here, isn't it? That will fall under your power rule. And at the same time, of course, even if there's an exponent there with your sine x, automatically there is an exponent which is 1. So that will fall under your power rule. That will fall under our power rule. So again, it will not be using this integration of trigonometric, but we will be instead we will be using your power formula. Again, your sine x will serve as your function u, and its derivative is cosine x dx. Your exponent is 1. So we will apply the power rule. According to power rule again, copy your u, add 1 to the exponent, and divide that 1 by the exponent. So that is what happened here. I copied your u, which is sine x. I added 1 to your exponent, so that will become squared, and divide that 1, of course, by 2. So that's why we have here your 1/2. And of course, plus your constant of integration, c. Okay, so any question with this example number 4? Because if none, then you will try this one in your own again, so that you will figure out if you know how to apply this integration of trigonometric function. Okay, so try your best to do this sheet work so that we will now be discussing. Don't worry, because we will be discussing this one on our live or online, yes, live discussion together with your questions with the previous examples. Okay, so we will be having a question answer in your next meeting. So we will be setting, of course, we will be using your schedule, your schedule in this subject, but we will be having an online discussion, so we will be using a Zoom. So again, just like before, we will be creating in advance your Zoom, and we will be uploading that link in the invite link in your Facebook page, so that all you need to do is click and then join. But of course, please join before the time starts, because especially since we are only using a free Zoom, we only have a limit of 40 minutes. Okay, so as much as possible, we will discuss all of this within 40 minutes. But if not, then of course we will create another session for that. Okay, so please try to integrate this example number 5. Try to do it in your own, so that you will see if you know how to answer this one. Because if not, then all you need to do is, again, go back and view our video. Understand, you can always play it back. Okay, so again, or if you have an advanced question, then you can comment this below this video so that we can prepare for that question. Okay, thank you very much. Okay, let's review these concepts. Trigonometric identities are useful in simplifying complicated problems in integral of trigonometric function. Yes, as you can see in our examples, the problems is not ready. The formulas. The problem is not in the form of our formula. Okay, so we need to put that one on the form of the formula for us to use the formulas. So that's why your trigonometric identities are, of course, really needed. That's why you really know how to make use of those. And then, of course, another concept is that the formulas for integration of trigonometric function can be used in conjunction with the power, logarithmic, and exponential. Okay, of course. It doesn't mean that since you have the trigonometric function, you only need trigonometric formulas. No. This could be collaborative together with the other integration formulas. Okay, so just like in our example number 4, we made use of your power. Okay, so that's it. So thank you for viewing.